AP Calc, we're back for the second part of Lesson 1 3.3. So we talked extensively about product rule and how for the most part product rule, if you can do an algebra first strategy, that algebra first is usually a cleaner process by which to find a derivative. When you have something like number 25 in the textbook, h of x equals 7 over x squared plus 5, there's not really an algebra first strategy here. You can't split the top up into two different parts here. Only if this were reversed. Multiple parts on top can split up with one on the bottom. This can't be simplified with algebra. We have to use quotient rule with the strategies we know so far. So, quotient rule. Quick recap. It looks as if we could say in an informal setting, or not an informal setting, but in an informal way, if y equals a top divided by a bottom, then the derivative can be kind of simplified in this way. Y prime equals the bottom times the derivative of the top. So I would just say t prime minus the top times the derivative of the bottom, b prime, all over b squared. Sometimes students have a much better time of memorizing this version of it than they do memorizing this version of it. So, I'm going to refer to this one probably more so than that one up here. Blue means take the derivative. Bottom is x squared plus 5. So, this is me not actually changing x squared plus 5 times the derivative of the top. Well, the derivative of 7, it's a constant, so it's just going to be 0. Okay? Subtraction after that, the top unchanged times the derivative of the bottom, which is going to be 2x plus 0, so just 2x, and then you're going to divide that by the bottom squared, divided by x squared plus 5 squared. So then 0 times this and 0 times that, it just completely zeroes itself out. So 0 minus 14x. Now here's the deal with the bottom. You don't actually have to expand this polynomial out. And it's not x to the fourth plus 25. It's not that. It'd be x squared plus 5 times x squared plus 5. And you'd have to do the algebra for that. I'm not asking for it. There's nothing more to be simplified on number 25. All right, so there's 25. I want to back up a little bit and do one more with quotient rule with, I don't know, more intense polynomials. It's over there in the corner, number 17. You guys try this on your own. Hit pause. All right, let's see if you're right. Bottom times the derivative of the top. 0 minus 1 plus 6z minus the top times the derivative of the bottom, 0 minus 9. All of that divided by the bottom squared. All right, so there's a lot more algebra to do on this one. What I'd probably do is just off to the side or on a piece of scratch paper, you're going to figure out what is that whole top part equal. This whole string of things. So I'm just going to say this is my scratch paper over here. I don't know. Let's get rid of this. So this is going to be 2 times negative 1, 2 times 6z, negative 9z times negative 1, negative 9z times positive 6z. All right. Then we've got negative 9, but there's a minus here. So this negative distributed to the negative 9, the blue and the black can be flipped because of the commutative property, and I can just say that this minus a negative becomes a plus. Okay, so it's going to be 9 times 8 plus 72. 9 times negative z minus 9z. 9 times 3z squared, which is going to be 27z squared. So these two z's cancel out. This is going to be negative 27z squared plus 12z, and this is going to be positive 70. So that's what appears to be on the top part of this fraction. All right, doing a quick check. That's the right answer. So here's the unfortunate part, is you got to do algebra. And the exciting part, you get to do algebra! Oh, if only everyone loved algebra. Okay, what's next on the list? Mosey on over to number 27. I personally love algebra. All right, 27. What is 27? Oh, good one. We're going to learn something from this example. Now, the first time students see this example, they try to use product rule on 1 divided by t squared. But I'm going to let you in on a little secret. You don't have to. Algebra first. Now, I can't do anything with t squared. It's about as simple can be. But 1 over t squared is the same as t to the negative 2. 1 over t squared equals t to the negative 2 power. I talked about exponents in depth a little bit a few days ago, so I'm just hoping you guys are okay with that. Ask questions in class if you're not. Once you get it to this part, now all we need to do to find the derivative is power rule on t squared, which gives you 2t, and then power rule on t to the negative 2. You bring the minus 2 down in front, t, and then you subtract 1 from negative 2. Should be to the negative 3 power. And then on your final move, make sure you rewrite this as 2 over t cubed. I'm not asking for common denominators, so don't feel compelled to do so unless you really want to. All right, what else did you guys want to see? Number 29. Oh, okay. The function of k of s to the negative 4 power. All right, here's the thing. I can't multiply something by itself a negative number of times, but here's what I can do. I can rewrite. So instead of distributing the negative 4 to both parts, why don't we just call this 1 over 3s to the positive 4th power? It's kind of the same idea that if you're a negative exponent, I can go back and forth between positive and negative exponents if I just switch it in whatever fractions it's in. So whatever part of the fraction it is in, if it's negative in one part, you just rewrite it in the other and it's positive. I can do something with this. I can actually multiply 3s times itself 4 times. 3 times itself 4 times is 81. S times itself 4 times is s to the 4 power. All right, so this is still an algebra first strategy. And you know what? I'm going to do some more algebra here. This seems kind of weird, but this s to the 4 that's on the bottom is a lot like the t squared that's on the bottom right here. What did we do with the t squared that was on the bottom? We rewrote it as t to the negative 2, because that would allow us to do power rule. Wait, I'm still not taking the derivative first. Hold on, Blue. So it's still 1 divided by 81. The 81's not going to move. But I can rewrite the s as 1 over 81 times s to the negative 4 power. Think of the s as it's on the top part of the fraction, but I'm looking at it as I have a coefficient times a power to a negative exponent. I think we're ready now. We're ready to find the derivative. So k prime of s is equal to, bring the negative 4 down and multiply by 1 over 81. That ends up giving you negative 4 over 81. Take 1 away here. And now we can move that negative right back into the bottom and make it positive. So is that the only way to do it? Certainly not. I mean, at this point, I could have done quotient rule. I could have distributed the negative 4 right away and done some different moves there too. But this is the path I chose, and yeah, you just got to keep going with it. So number 29 is done. I have 2 more for you, 35 and 37. Come with me to the other side of the board. Oh, this one is weird. So it's 3 divided by 5t. Minus 1 on the top. 2 divided by t squared. Plus 7 on the bottom. Now, this is a little bit strange. We could go to product rule right away, or we could do algebra first. What I mean by algebra first is we can get one numerator and one denominator. Like these fractions inside of the fractions are just overcomplicating things. So I'm going to rewrite this as the numerator divided by the denominator. Whoa, you couldn't see any of that. My apologies. So I took the numerator divided by the denominator, and now I can find common denominators. So this would be times 5t times 5t. That'd give me 3 minus 5t over 5t divided by times t squared times t squared. It's going to be 2 plus 7t squared all over t squared. Can you guys still see that? I can see it. I hope you can see it too. Then I can keep the first fraction, change the sign, flip the second fraction. I can cross cancel a t here with a t there. But I can't cross cancel this t with that t because there's subtraction. Basically, the polynomials would have to be identical there in order for cross canceling to happen. So f of t is equal to t times 3, t times negative 5t, all over 5 times 2 plus 5 times 7t squared. All right, I'm not saying that's the only way you can do this. I'm just saying an algebra first policy on this particular one gets us one polynomial divided by a second one. And quotient rule is going to be a little less cumbersome with all the fractions floating around. So quotient rule says bottom, leave it alone, times the top derivative, 3 minus 10t. Then you'd subtract the top times the derivative of the bottom, 0 plus 70t, divided by the bottom squared. My apologies, the video is going to run a little long on this, but I think we'll be okay. All right, so let's bring it closer to the actual viewing audience. We got to do some, let's do off to the side the multiplication here. So 10 times 3 is 30. You guys can see that? Yeah. 10 times negative 10 is negative 100t. 105t squared. Minus 350t cubed. All right, and this minus is going to basically be attached to the 70t. So then you've got negative 210t squared. And then a negative 70t times a positive 5 is going to be 350 positive t cubed. All right, and that pretty much covers everything on the top. The t cubes cancel. You're left with negative 105t squared minus 100t plus 30 on top of that fraction, divided by 10 plus 35t squared. And you know, now that I'm looking at this, I would accept this as a final answer, okay? No question. But I'm also recognizing that 10 and 35 share a 5, right? So technically on the bottom, I could factor out a 5. And everything is still squared here. But I can distribute that squared and call this 25 and call this squared. And then I could take a 5 out of every part of the top. So that'd be negative 21t squared minus 20t plus 6. So it'd be something like that. That might be the simplest simple version. All right, maybe I don't even need to do 37. Let me check it. All right. 37 will be my last one. Kind of a long video. That's okay. I apologize and you accepted. So 37. All right. A bunch is happening on top. and the bottom is a single party. Now, you can certainly do quotient rule if you want. However, you can use algebra on this to make it you can use algebra on this by dividing each part by x squared. You can split fractions up. Sorry, this is getting in the way. You can split fractions up if there's a single bottom and multiple tops. You can't do it if there's multiple bottoms and a single top. So you can do 2x cubed over x squared minus 7x squared over x squared, and so on. Why is this helpful? Well, because 2x cubed over x squared is just 2x. That's a simple derivative. 7x squared over x squared is just 7. That's a simple derivative. 4x over x squared is 4 over x. If I rewrote that as 4x to the negative 1, that's a simple derivative. And then 3 over x squared, if I rewrote that as 3x to the negative 2, that's also a simple derivative. So let's take that simple derivative. M prime equals 2 minus 0, so I'm just not going to write anything, minus 4x to the negative 2, minus 6x to the negative 3. So this is 2 minus 4 over x squared minus 6 over x cubed. All right, guys. Thank you for your endurance and your patience on this video. I hope it was enlightening. I hope you learned something. I hope you know what's going on with product rule and quotient rule now. That's all.